Hello, ladies and gentlemen, and welcome back. We are still looking at the 2016 Hypatia contest, and we are on question number 2. If a line segment is drawn from the center of a circle to the midpoint of a chord, it is perpendicular to that chord. This is true. This is a nice little circle geometry fact, that radii always bisect at a perpendicular angle any chord. Okay? So, they're just catching that up to speed. Circle geometry isn't always gone through in school. Certainly, perhaps not in time for a grade 11 contest. For example, in figure 1, OM is perpendicular to chord AB. If a line segment is drawn from the center of a circle and is perpendicular to chord, it passes through the midpoint of that chord. So this is sort of the reverse. Okay? So this is what we've got with figure 2. If you know you're heading at a perpendicular angle, you split this in half. Okay, nice little circle geometry facts. We're up to speed if we didn't already know them. Okay. What have we got here for question 2? We've got 2 light bulbs and a written. In the diagram, a circle with radius 13 has a chord AB of length 10. If M is the midpoint of AB, what is the length of OM? Okay. So let's draw our picture here in our notes. OM, and we're told M here is the midpoint. But what did we just learn? If M is the midpoint, then this must be a right angle. Okay, because O is the center. So we've got 13 here. So what we can say is AM is equal to MB. They're both 5. Why are they 5? Well, they're half of the total AB, which we are told is 10. Okay. We might say angle OMA is 90 degrees, and you would say it, although it's a light bulb, we don't have to say it, but just as practice for the written part, we would say OMA is 90 degrees, since O is the center, and M is the midpoint of AB. So we are using this this first fact here, that if you're the midpoint, then yeah, it's 90 degrees. Okay. So now what have we got? Well, we've got a right angle triangle. So we could say by the Pythagorean Theorem applied to this triangle here. We know this is 5, this is 13, and you might remember your Pythagorean triples. 5, 12, 13 is really common. So we might say by the Pythagorean Theorem, OA squared is AM squared plus MO squared. We are trying to find MO, right? Yeah. OM, whatever. So that's 13 squared is 5 squared plus, I'll rewrite it as OM squared. And you could rearrange it. Grab your calculator if you need to. 13 squared is 169. And 25 plus OM squared. You'll realize 144 is OM squared. So OM, and this is all we need for our final answer, OM is 12. Okay, so that length is 12. Okay, so that gives us the answer to A. How about B? In a circle with radius 25, just before we get into this, I'm predicting one of 2 possible triangles just because I know my Pythagorean triples. So I think we're either going to see a 25, a 15, and a 20, or we might see a 7, 24, 25. Okay? These are really common Pythagorean triples, Pythagorean triangles, so they're good to know. Because already, just by reading radius 25 and knowing that I used a right angle in the last question, my mind starts conjuring up ideas of, okay, what triangles might we be using? But let's continue on. In a circle of radius 25, a chord is drawn so that its perpendicular distance from the center of the circle is 7. So we're going to be using this one. What is the length of this chord? Okay, let's draw the picture of what they're talking about. So we'll say O here, and we've got a chord so that its perpendicular distance is 7. So if we connect up these sides here, you might say something like, call the chord AB. Okay, and we want the length of the chord, right? What is the length of the chord? Alright, so M is thus the midpoint of AB. So we might say the length of AB is 2 times the length of AM. So now all I need to figure out is this length here. Well, I've got a 7 here. OA is 25 because it's a radius. So again, we use the Pythagorean triangle, or the Pythagorean theorem, or we remember our Pythagorean triple, 7, 24, 25. So you can say AM squared is 25 squared minus 7 squared. You can say by the Pythagorean theorem if you need to. 625 minus 49 is going to be 576, which is 24 squared. So AM is 24, and the answer that we want the length AB, well that's 2 times the length of AM. So that should be 2 times 24. So 48. This chord is a length 48. Okay? And 48 is all we need for our answer. But we did bother to show some work just in case we had a bad calculation. Alright, now C, we do have to write everything up. We do have to say it by the Pythagorean theorem, and because this is a midpoint, I know this is perpendicular, all that fun stuff. Alright, C, in the diagram, the radius of the circle is 65. I'm thinking 5, 12, 13 triangle already, but I could be wrong. Of course I could be wrong. It could be the 3, 4, 5 triangle, and everything's multiplied by 13. Who knows? Or it might not be integers. Anyways, let's continue reading. 2 parallel chords, ST and UV, are drawn so that the perpendicular distance between the chords is 72. So MN is 72. If MN passes through the center of the circle O, and ST has length 112, determine the length of UV. Okay. So we got 2 parallel chords. They're not necessarily the same distance from O, so we could have ST be really close and UV still perpendicular but further away. But because they're... Actually, did they say... So circular radius 65, parallel chords drawn, perpendicular distance between them. So now I can add in those right angles. Okay, but it passes through the center. So we can see, we'll just say, we see M and N are midpoints of ST and UV respectively. Okay, I'm also going to draw in some radii, so 65 here, 65 here. I know it's not exactly a symmetric looking picture, look like it should be. There we go, 65s. Alright, so that length the same as that length, even though it doesn't quite look it in my picture, and SM is equal to MT. Now, I know that OM plus ON is 72, but I don't actually know which length is which. So, although I'm willing to bet that I'm going to use the 3, 4, 5 and the 5, 12, 13 triangles here. So ST has length 112. So I can use that. So 112. So SM is 1/2 the length ST. So 1/2 of 112. And that's going to be 56. So I got a 56 here. So you might say triangle OMS is right angled. So by the Pythagorean theorem, or by Pythagoras, or whatever you want to say, OM squared is the hypotenuse squared minus this known side length squared. Okay. And, 65 and 56 don't have values in common. Interesting. They don't have a factor in common. That's okay. Because I can just grab my calculator here. 65 squared is 4,225 minus 56 squared. 3136. And I'll get 1,089, which I recognize, although you could confirm on your own, is 33 squared. Okay, so that tells me what? OM is 33. Now I know MN is 72, so ON is 72 minus 33. And that's going to be what? 49? No, 39. Okay, so 39. So ON is 39. Now if we go back to our picture, all right, 39 here. And what do we want? We want the length of UV. Well, that's going to be double the length of, say, NV. And I can use the Pythagorean relationship to figure out NV. By the Pythagorean Theorem in triangle, what was it? ONV. 65 squared minus 39 squared is going to be NV squared. 39 is 3 times 13. 65 is 5 times 13. So NV should be 4 times 13. So that'll be 52 squared is NV squared. So NV is 52. And since N is the midpoint, we could say that. Since N midpoint, UV, oops, not UN, UV is 2 times NV, so 2 times 52, so that's 104. And we were asked for the length of UV, so there we go, but we've justified it. We said when we use the Pythagorean identity, we mentioned that M and N must be midpoints, those sorts of things. So everything's good to go. We showed all our calculations, and that wraps up question 2 quite nicely. So join me in the next video. We are just over the halfway point of our Hypatia contest, and we're going to look at question 3 in the next video. I will see you there.